For each positive integer n, let fn be the function defined on the interval 0, 1 by fn of x is equal to x to the n over 1 plus x to the n. Which of the following statements are true? Okay, we've got three statements here. The sequence converges pointwise on 0, 1 to a limit function. The sequence fn converges uniformly on 0, 1 to a limit function. And this integral statement. I'll have to make some sense of that later. Okay. I think the best approach here is to try and understand what these functions look like. So we're only on the interval 0, 1. So f of 0 is always 0. F of 1 is always 2. And what do these functions look like? Well, okay, as n, when, I don't know exactly what these look like, but for very large values of n, this is going to be small, right? X being less than 1 means that's extremely small. That's extremely small. So in the denominator, this part is negligible. Okay, so for very large values of n, the function looks something like this. In fact, if I go for even larger, it's probably going to something like that. So for fixed x, if I take this limit, this is equal to 0 for x not equal to 1, and 1 for x equal to 1. Okay, so that's the limit function. But the convergence isn't uniform. The convergence isn't uniform because close to 1, like here, how do I, you can, like, first of all, if the convergence were uniform, the limit function would have to be continuous. Okay, so that's a statement which is clearly violated here. So we can't have uniform convergence. This means, 1 is correct. 2 is not a correct statement. But what about 3? This statement about the integral. Limit n to infinity, the integral 0, 1, f of n x dx equal to the integral 0, 1, of the limit. Okay, so this is 0. That equals 0. So we're asking if the limit as n goes to infinity of this integral fnx dx is equal to 0. And that's going to be true. I think in fact, it follows from, what does it follow from? I mean, we have pointwise convergence of bounded functions. Is there an option for 1 and 3? Yeah, so option D is correct. 1 and 3 are true. Yeah, is it dominated convergence theorem that's applying here? I mean, we have a sequence of functions which are all bounded. They converge pointwise. Everything is integrable. The limit function is integrable. So the limit of the integrals converges to the integral of the limit. In fact, there's a Now it's not a monotone convergence because it's decreasing. Anyway, that's my answer, D. Really just testing whether you understand different, the concepts behind different types of convergence, and whether you have a good intuition for what these functions look like depending on n. Yeah, not much more to say about this one. If there's a mistake somewhere, I'll let you know. Thanks for watching.